So we're going to look at comparing proportional relationships today. So we're going to start by going over a summary here. We've been talking about proportional relationships quite a bit, and there's different ways these can be represented. You can have words like a sentence that talks about a proportional relationship or a unit rate or something like that. You can have graphs, you can have charts, equations. There's lots of different ways you can see it represented. The point of today is to be able to compare two different forms. So like it says in the second little part here, it says you'll need to be able to understand how to find the constant of proportionality, which is like the unit rate or the K, from each type in order to compare them. So that's the whole goal for today, being able to compare these proportional relationships. So one way we talked about in class is to look at a graph, right? So I'm going to go through a couple different ways how we can figure out the slope. So like you see up here, there's like different ways to say this. The slope, the unit rate, the constant of proportionality. They all mean the same thing. But how to find it from a graph. So the first thing is you can count rise over run from point to point. This is just like doing slope. Okay, slope is rise over run. Okay, so when I look at my graph, I can pick any 2 points. So let's just say I'll pick these 2 points here. It could be any 2 points. I'm going to take those 2 though. Okay, and I'm going to go from the left point to the right point, and I have to do my rise first and my run second. So if I'm going to rise up, I'm going up. Now you have to be careful sometimes. Here I'm going up 2 squares, but my rise is not 2, right? I'm going from 24 up to 48. So my rise is 24, okay? My run, I'm going 2 squares to the right. That's actually 2. I'm going from 2 to 4. That's actually 2. So you always have to check the scale that you're going by. So like here, I'd say my rise is $24. My run is 2 hours. Okay, you get your label from what it is on the y-axis, that's the label for the top, and what it is on the x-axis, that's the label for the bottom. Okay, so if it's $24 for every 2 hours, I can simplify that by 2. I'd say that'd be $12 for 1 hour, right? Or $12 per hour, same thing. Okay, from a graph, you can also do this. You can find this point. When x is 1, what does y equal? That would be your unit rate, right? So over here, when x is 1, so here's when x is 1, I go up and I run into my line, then I go and try to figure out what would y be. So here it looks like when x is 1, it looks like y would be 12, because these little notches are going by 12. That would mean $12 per 1 hour, which is the exact same answer we got up here, right? It's like we're finding the same answer, just different ways. So that's another way to do it. Another way, if you have a graph, you can use y equals kx, okay? You can do that with any point. So if I go over here, I pick a point. Let's say this point, right? I'm just trying to pick different points. Y equals kx. Okay, I'm going to replace the y and the x in that formula. On this point right here, let's figure out what the x and y are. That point, it looks like the x is an 8, okay? And the y looks like 96. So I'm going to say x is 8, y is 96. Right? This is my x, this is my y. The y goes here, the x goes here. So I'm going to put this in here. 96 equals, now instead of saying k8, like k times 8, k8, we know we write that 8k. That's kind of the way you write it. Okay, so now if I solve this little mini equation, I divide by 8s, you're going to get k equals 12, right? That means $12 per hour. Same answer. One last way, if you have a graph, just do y divided by x with any point. Let's take that same point. We just said this was x is 8, y is 96, I think. Yeah, we could do y divided by x. So this would be $96 divided by 8 hours. 96 divided by 8 is $12 for 1 hour. So lots of different ways if you have a graph that you can find the unit rate, the K, it's all the same thing. Lots of ways you can figure that out. Okay, going down here. If you have an equation and it's in slope-intercept form, or y equals, I guess I should say, y equals kx form, right? As long as it's like that, k is the slope. The slope is the same thing as your unit rate. So if it's y equals kx, if everything here matches up, y equals kx, right? And there's nothing else out here at the end of it, there's nothing else that looks weird, you would just say whatever this is, the coefficient of x is your unit rate, is your constant rate. So here it's just k would be 5. So you can tell from an equation. You can also tell from a table, right? Or a chart like this. So if you have this, what you kind of want to do is set up some little ratios. So here they're saying you have servings and calories for serving A and serving B, right? So we always say the first thing that they list, it kind of goes alphabetical, like X, then Y. But when you go to make your ratio, you want to do Y divided by X, like it says right here, Y divided by X. So that would be calories divided by servings, right? So if you look at A, that would be 310 calories divided by 2 servings, right? And you look at B, that would be 775 calories divided by 5 servings. Okay, so we're trying to figure out the calories per serving, the calories divided by the servings. So if I go here, these should both theoretically be the same thing. Or I guess maybe if we're just comparing, I don't know, let's see what happens here first. So if we do 310 divided by 2, I'm going to get 155 calories for 1 serving, right? So if I'm trying to look at this other one then, I'd say, okay, 775 divided by 5, you would also get 155 calories for 1 serving. So these are the same. They're the same, like, item that's being served, right? So the whole point of this is we could take a unit rate from this, from a chart, and say, okay, are there more calories per serving based on this chart or in this equation, right? And you can compare them because you can find the constant of proportionality in both. Then you just compare that number. So like, for example, here's what we're talking about, okay? So this one says, Charlie took a test that showed he can type 700 words in 5 minutes. The fastest recorded typing speed is shown in the chart below. So this is like the fastest person ever. They could do 216 words in 1 minute. Does Charlie type faster than the record shown? Yes, no, or it's the same. So in order to compare these things, like this one's already good. This is already how many words in 1 minute. That's what we want to figure out. Charlie's is words in 5 minutes, right? Down here, there's no 5-minute comparison. So I'm going to break it down to this is how many words in 1 minute. And I want to figure out Charlie, how many words in 1 minute for him. So we're going to say 700 words in 5 minutes, right? We're just going to divide these two things. So 700 divided by 5, you're going to get Charlie can type 140 words in 1 minute. So now you need to ask yourself, does he break the record, right? Here's what Charlie does, 140 in a minute. Here's what the fastest ever person did, 216 in a minute. Does Charlie break the record? Is he faster? No, that's still pretty good typing, but it's not the best in the world ever speed. So we'd say, no, he doesn't break that record. What we did was we compared a sentence. We found that unit rate. We compared it with a graph, like a chart, right? Like a table. Okay, we're going to be doing that a lot. So we have to be able to determine the unit rate from all kinds of things and then be able to compare them, say which is bigger, say which is smaller, that kind of thing. Okay, see you guys later.